Hello class, welcome to the next segment in the week 13 material, and in this segment we're going to take a closer look at the TOS or the sea surface temperature data that we had earlier. And in this segment I'm actually not going to be doing this in GNE because there's a lot of visual representations that I'm going to employ to sort of illustrate what's going on here. But this is the exact same code, pretty much essentially the exact same code that we had before, just put in sort of a presentation style. And here we're going to take a closer look at the actual data set that we're going to be working with, which contains all of our sea surface temperatures. So first off, everything up here looks the same. And down here I have x equals the underscore data 0, 0, 0, all that contained within the brackets. Remember, excuse me, remember that the underscore data, our sea surface temperature array, that is in fact a three-dimensional array. And remember that way three-dimensional arrays or multi-dimensional arrays work is you have a single set of brackets and then each dimension is separated by commas here. So this is the value I want out of the first dimension, this would be the value I want out of the second dimension, and this would be the value I want out of the third dimension. And then I take that number, put it in x, and then print out what the value of x is. So this would work just like any other Python program. But I do want to go ahead and reiterate something that's very important to keep in mind. The first value that you put in here inside of our array, that is in fact the time dimension. The second value that you put in is the latitude dimension, and the third value that you put in is the longitude dimension. Keep that order in mind as we go forward. The first number here corresponds to a time, the second number corresponds to a latitude, and the third value corresponds to a longitude. Now you might be wondering, now hold on a second. There's no value of 0, there's no value of 0 for latitude, there's no value of 0 for time, there's no value of 0 for longitude. What's going on here? And the reason why is because the values that you put inside the brackets here, those are not the actual values. The 0 that you put in here, that is not time equals 0, that's time number 0 out of our time array, which was defined up here. That corresponds to time number 0 out of our time array up here. And the value of 0 here, that corresponds to our latitude array that we have defined up here, item number 0 in our latitude array, and this 0 right here corresponds to item number 0 in our longitude array. So if we really want to tie this back to something that's a little bit more relatable, we have to take this 0 here and find out what time number 0 is, and then from our table we can see time number 0 is in fact 15. And remember, the units for that are 15 days since January 1st, 2001, which is right in the middle of January. So by putting a 0 in the time dimension, I'm warning the value at time number 0, and time number 0 is 15 days since January 1st, 2001. By putting in the 0 for the latitude dimension, that is not 0 degrees north or 0 degrees south. Doesn't really matter because it's the equator. That is not 0 degrees north. That is latitude. That is the value at latitude number 0. What's latitude number 0? It's negative 79.5, given by the table of values that we had derived earlier. And then finally, the 0 in the longitude dimension here, that in fact corresponds to longitude number 0, or item number 0 out of the longitude array we attained up here, and that value is in fact 1. So this entire thing is going to access the sea surface temperature value at, or on January 1st, 2001 at 79.5 degrees south and 1 degree east, and print out what that sea surface temperature measurement is. And I'm going to pause a minute to sort of let all that sink in, as this might get kind of confusing. I'm just going to go ahead and reiterate this now, and I'm also going to reiterate again with a lot of extra emphasis, but you don't put the actual values in here. You put in values that reference the arrays that were defined up here. So item number 0 means I want the sea surface temperature at time number 0, which is 15. At latitude, when I'm putting a 0 in here, I want the sea surface temperature at latitude number 0, which corresponds to entry number 0 in the latitude array, which is 79.5 degrees south. And then by putting the 0 in for the longitude here, that means I want the sea surface temperature at longitude number 0, which corresponds to the 0th entry in this longitude array, which is 1 degree east. And just to take a look at another example, so here instead of 0 being put in the time dimension, I'm putting in 1 for the time dimension, and that means I want the sea surface temperature measurement at time number 1, which is 45 days since January 1st, 2001, or February 2001. And then by putting the 10 in here, I want the value from that time. I also want latitude number 10, which corresponds to item number 10 in the latitude array, which is this value right here, 69.5 degrees south. Remember, the negative corresponds to a value in the southern hemisphere. And then by putting the 5 in here for the longitude, I want longitude number 5, which corresponds to longitude number 5 in this longitude array, which is this value of 13. So this entire thing would give me the sea surface temperature measurement on February 1st, or February 2001, not necessarily the first of the month, but February 2001 at 69.5 degrees south and 13 degrees east. Now, I am going to show you now a very, very common mistake that I see all the time, semester after semester. It's probably going to be very tempting to put the actual time, latitude, and longitude values into the brackets. Remember back in week 5 and week 9, when we said the values that you put inside of the brackets, whether it's in a list or an array, those have to be integers. You cannot put decimals in there to begin with. So this is not going to work. And hopefully you're taking what you see on the screen right now and drilling it into your brain, because if at any point you get the temptation to put the actual time, latitude, and longitude inside the brackets, tell your brain to stop, don't do it, don't go down the path of confusion, because it's a very dark and dangerous path you don't want to go down. So if at any point you get the temptation to put the actual latitude and longitude values inside the brackets, or the actual time value inside the brackets that we had earlier, don't do it. Tell your brain to stop. Don't even think about it. Remember, the numbers that you put in here, those are not the actual time, latitude, longitude values. Those numbers point to the actual time, latitude, longitude values, and the way they point to it is they reference the arrays that we have defined up here. So when we say we want time number 1, or if we really want 45 days since January 1st, we have to put in the corresponding index to our time array. We have to put that corresponding index inside the brackets here. And then same thing for the latitude array. If we want a specific latitude, say 69.5 degrees south, then we have to put this number, this 10, inside our latitude dimension when we're going to pull the sea surface temperature data out. And then finally, if we want 13 degrees east, we have to take that 5 and put it inside the value for a longitude dimension to get the sea surface temperature measurement at that longitude. So that's a look at the three-dimensional data set that is the sea surface temperature data set that we're working with. If this is still kind of confusing, I would recommend just walking through the videos until it makes sense. And if you want to, you can play around with the data set, plugging in different combinations of values for the brackets here and seeing what works. But I'll just go ahead and iterate this one more time because it's so important. In fact, it wouldn't be a bad idea to just take a mental snapshot of what you see on the screen here and just stare at it for a long minute so that you don't get this temptation at any point in the future. So that's going to do it for the week 13, or excuse me, this segment of the week 13 material. And in the next couple of segments, we'll take a look at some NumPy functions that can make calculations a lot easier when we're working with large data sets like this. So with that, I will see you guys in the next segment.